When people talk about operating systems, the conversation usually revolves around market share. Windows still dominates desktops, Mac OS remains popular among creative professionals, and Linux is often described as the operating system for programmers and servers. But something remarkable has been happening over the past few years. Linux is no longer simply catching up to Windows in certain areas. Instead, it has begun moving in directions that Windows simply cannot follow without completely changing its identity. That doesn't automatically make Linux better for everyone, but it does suggest that the future of operating systems may look very different from the past. For decades, Windows was built around a single philosophy. Microsoft developed the operating system, decided its direction, and users adapted to those decisions. Linux, on the other hand, evolved through a completely different model. Thousands of developers, companies, universities, and volunteers contribute to different parts of the ecosystem. Instead of one company deciding everything, innovation happens from many directions at once. This decentralized approach often seems chaotic, but it also creates an environment where experimentation happens much faster than in traditional software development. One of the biggest changes is how Linux distributions have matured. Years ago, installing Linux often required technical knowledge, command line expertise, and plenty of troubleshooting. Today, many distributions provide polished installers, hardware detection, graphical software centers, and user-friendly desktop environments that rival commercial operating systems. New users can install distributions like Ubuntu, Fedora, Linux Mint, or Pop! OS with surprisingly little effort, making Linux far more accessible than it was a decade ago. Customization has always been one of Linux's strengths, but it has reached an entirely new level. On Windows, users can change wallpapers, themes, and a few interface settings, but the overall experience remains controlled by Microsoft. Linux users can choose between desktop environments like GNOME, KDE Plasma, Cinnamon, XFCE, and many others. They can even replace nearly every visible part of the interface, creating workflows that perfectly match their personal preferences rather than adapting to a fixed design chosen by a corporation. Another area where Linux has crossed an important line is privacy. Modern operating systems increasingly collect diagnostic information, usage statistics, and cloud synchronization data. While much of this telemetry is intended to improve products, many users prefer having complete control over what information leaves their computers. Most Linux distributions either collect no telemetry by default or make data collection completely transparent and optional. This level of user control has become increasingly valuable as digital privacy concerns continue growing worldwide. Software installation has also evolved dramatically. Traditional Windows software often requires downloading installers from various websites, each with different update mechanisms and installation processes. Linux introduced centralized package management decades ago, allowing users to install applications from trusted repositories with automatic dependency handling. More recently, technologies like Flatpak, Snap, and AppImage have expanded software availability while simplifying installation across different distributions, creating an ecosystem that continues becoming more flexible every year. Security represents another area where Linux has steadily gained momentum. Because Linux permissions separate administrative access from everyday usage, malware generally faces greater barriers before making system-wide changes. The open-source nature of Linux also allows security researchers worldwide to inspect source code, identify vulnerabilities, and contribute fixes quickly. While no operating system is perfectly secure, Linux benefits from a development model where transparency often accelerates security improvements rather than hiding problems behind closed development processes. Perhaps the most significant transformation is happening behind the scenes with artificial intelligence. Linux has become the preferred operating system for AI researchers, machine learning engineers, cloud computing providers, and supercomputers. Most AI frameworks are developed and optimized on Linux first because of its flexibility, scripting capabilities, and compatibility with high-performance computing environments. As artificial intelligence becomes central to future computing, Linux already occupies the foundation on which much of that innovation is being built. Cloud computing tells a similar story. The overwhelming majority of Internet servers, cloud infrastructure, web hosting platforms, and enterprise services run Linux. Every time someone streams a movie, visits a website, uses online banking, or interacts with cloud-based applications, there is a very good chance Linux is working behind the scenes. Windows remains important in enterprise environments, but Linux has become the backbone of modern Internet infrastructure in ways most users never realize. Containerization has pushed Linux even further ahead in software development. Technologies like Docker and Kubernetes rely heavily on Linux capabilities, making it the standard platform for deploying modern applications across cloud environments. Developers increasingly build software that runs inside containers rather than targeting a single operating system directly. This shift means Linux isn't just competing with Windows anymore. It is becoming the underlying platform upon which future software ecosystems are constructed. Gaming was once considered Linux's greatest weakness, but even that narrative has changed dramatically. The development of Proton has allowed thousands of Windows games to run on Linux with impressive compatibility. Combined with improvements in graphics drivers, Vulkan support, and gaming-focused distributions, Linux gaming has reached a point where many players can enjoy extensive game libraries without leaving the platform. While certain competitive titles and proprietary anti-cheat systems still present challenges, the overall gaming experience has improved beyond what many people imagined possible. The rise of handheld gaming devices has also shifted public perception. Systems built around Linux have demonstrated that open-source software can deliver polished gaming experiences to mainstream consumers. Instead of treating Linux as an experimental platform, hardware manufacturers increasingly recognize it as a practical foundation for specialized computing devices. This trend suggests Linux's influence extends well beyond traditional desktop computers. Another important reason Linux is moving in directions. Windows cannot easily follow his licensing. Linux is open source, meaning anyone can study, modify, distribute, and improve its code within the terms of its licenses. Microsoft could release more source code, but transforming Windows into a community-governed operating system would fundamentally alter its business model. Linux's openness encourages collaboration across companies that might otherwise be competitors, allowing innovation to spread rapidly throughout the ecosystem. Energy efficiency is becoming another increasingly important consideration. Lightweight Linux distributions can breathe new life into older hardware, extending the lifespan of computers that might otherwise become electronic waste. This flexibility benefits schools, developing regions, businesses seeking lower costs, and environmentally conscious users. Instead of forcing hardware upgrades every few years, Linux often allows existing machines to remain useful for much longer, reducing both expenses and environmental impact. The modular nature of Linux also enables entirely new categories of computing devices. Embedded systems, smart appliances, automotive infotainment systems, industrial equipment, networking hardware, and even space missions frequently rely on Linux because developers can include only the components they actually need. Windows has versions designed for specialized hardware, but Linux's adaptability makes it uniquely suited for an enormous variety of computing environments beyond traditional personal computers. Community involvement remains one of Linux's greatest strengths. Users don't simply consume the operating system, they actively shape its future. Bug reports, documentation, translations, accessibility improvements, artwork, programming contributions, and financial support all help drive development. This collaborative culture creates an ecosystem where users often become contributors, resulting in software that reflects the needs of diverse communities rather than solely commercial priorities. None of this means Windows is disappearing anytime soon. Millions of businesses depend on Windows-specific software, enterprise management tools, and workflows that have evolved over decades. Many professional applications continue offering their best support on Windows, and Microsoft's ecosystem remains incredibly strong across productivity, gaming, and commercial environments. Windows still serves countless users extremely well, and it will likely remain an important operating system for many years. However, the definition of computing itself is changing. Instead of asking which operating system has the largest desktop market share, we should ask which platform powers cloud infrastructure, artificial intelligence, software development, scientific research, embedded devices, and future technologies. Increasingly, the answer is Linux. Its influence extends far beyond laptops and desktops into nearly every layer of modern digital infrastructure. The real milestone isn't that Linux has become identical to Windows or replaced it everywhere. The milestone is that Linux has matured into something fundamentally different. It is no longer trying to imitate Windows. Instead, it has established an independent vision built around openness, transparency, flexibility, collaboration, and user choice. Those qualities allow Linux to evolve in directions that proprietary operating systems often struggle to match because of commercial constraints and legacy expectations. As we look toward the next decade, the future of operating systems may become less about a single dominant desktop platform and more about adaptable ecosystems that power everything from AI clusters to handheld gaming devices, from personal laptops to autonomous vehicles. In that future, Linux isn't simply participating in the race, it is helping define the track itself. And that is why many technology enthusiasts believe Linux has crossed a line that Windows cannot easily follow. Not because Windows has failed, but because Linux has embraced a model of innovation that continues expanding beyond the limits of the traditional operating system.